Hello, this is Jack Jackson. In this video, we're going to start with a series of videos talking about the classification and properties of quadrilaterals in Euclidean geometry. Now, this material is kind of a summary of what's gone on in the last couple of playlists, and this playlist will summarize a lot of that. And this is going to be the first of a series of videos where I'm using this rather large GeoGebra uh, activity where I have basically cataloged all different kinds of quadrilaterals. So we start here with the introduction, and we see that quadrilaterals are defined to be four-sided polygons. And this places them in within this hierarchy structure over here where we start with geometric figures, any set of points that we have. We have continuous curves, plane curves, simple curves, closed curves. If they are a simple closed plane curve, that's a closed plane figure. If they're made up entirely of line segments as a polygonal curve, and so that would include things like line segments. There should be simple plane curves as well. Lines and rays would be simple. And then polygons are closed plane figures that are also polygonal curves. Notice circles are also closed plane figures. And then polygons we can classify according to their number of sides. Triangles have 3 sides, quadrilaterals, pentagons, hexagons, and so forth. And we're going to focus in on quadrilaterals here for a while. Notice that we can look at this, and there are many cool types of subclasses of quadrilaterals. So quadrilaterals gives us a very rich and robust collection of geometric figures to study and classify. And within this big activity that I have here, we can select and deselect certain things here. So for example, we can select this, which gives us a hierarchy among the most common forms of quadrilaterals, giving us a taxonomy of quadrilaterals. So the main ones that people will study are quadrilaterals, concave and convex quadrilaterals, kites. A concave kite is called a dart, and then we have concave kite is a dart. Convex kites we have as well. We have trapezoids, and trapezoid is a quadrilateral with at least one pair of parallel sides, so that's going to include parallelograms, isosceles trapezoids, and right trapezoids. Isosceles trapezoids and parallelograms both have a pair of congruent legs, so I call those isoleg trapezoids. That's kind of my own word for that. We have cyclic quadrilaterals, ones where you can circumscribe a circle around that where it hits all the vertices. And this is my own word for this, tangential quadrilateral, where all the sides are tangent to a inscribed circle there. Parallelograms, isosceles trapezoids, right trapezoids, rectangles. If it's any two of these three, then it's a rectangle. A rhombus is both a convex kite, tangential quadrilateral, and a parallelogram. And a square is both a rhombus and a rectangle. So you can see the basic setup there. And that is with these following definitions. So these are the basic definitions. Quadrilateral is a four-sided polygon. A convex quadrilateral is a quadrilateral with a convex interior. In other words, if 2 points are in the interior, then all points between them are in the interior. A concave quadrilateral is just a quadrilateral that's not a convex quadrilateral. A kite is a quadrilateral with at least 2 disjoint pair of consecutive congruent sides. A dart is a concave kite. A right quadrilateral is a quadrilateral with at least 1 right interior angle. A trapezoid is a quadrilateral with at least 1 pair of parallel sides. In a trapezoid, the parallel sides are called bases and the other sides are called legs. And interior angles whose intersections is a base are called a pair of base angles. A right trapezoid is a trapezoid with at least 1 right interior angle. An isoleg trapezoid, this is kind of my own thing, is a trapezoid with congruent legs. That's going to include parallelograms and isosceles trapezoids. An isosceles trapezoid, by definition, is a trapezoid with a pair of congruent base angles. We can prove that it's going to have congruent legs. A parallelogram is a quadrilateral with 2 pair of parallel sides. A cyclic quadrilateral is a quadrilateral such that there exists a circumscribed circle that contains all 4 vertices. More generally, a cyclic polygon is a polygon that admits a circumscribed circle containing all the vertices. A tangential quadrilateral, my word, is a quadrilateral such that there exists an inscribed circle that is tangent to all four sides. And again, we could have a tangential um, um, polygon in the same idea. A rhombus is an equilateral quadrilateral. In other words, all four sides are congruent to each other. A rectangle is an equiangular quadrilateral. All four interior angles are congruent. And a square is a regular quadrilateral, that it is both equiangular and equilateral. So just to get us started, here is a general quadrilateral. And so you can manipulate these. Notice that the lengths of the sides are shown. And you can manipulate it so that you can get basically any possible quadrilateral. Convex, concave. You can manipulate it so that it's not a quadrilateral, so it's no longer simple right here. So that's not a quadrilateral. Okay, notice that it is a planar figure. All the points are in a single plane. When you click any of these things, or at least most of them, and you click on this, it will have angle markers and show you the angle measures. I have it set in radians at the moment, but you could go to the settings and change it to degrees if you'd rather. And there we have it. This is technically not, technically that is the interior angle, which is always an angle between 0 and 180 degrees, or 0 and pi radians. You can show the diagonals. First diagonal, which will always be AC. I'll always label this in such a way that it's always A, B, C, D. And then you can show the other diagonal there. You can show the interior of it, which is this, and the number there is the area of that shaded area, which is the interior, which is not actually part of the polygon. The polygon, the quadrilateral here, has the interior, the exterior, and the polygon itself is just the four line segments. And you can click on this to see properties. Here's properties of all quadrilaterals. It's a closed, simple, plane polygonal curve. It's a four-sided polygon. It has four vertices and four interior angles. It has 8 exterior angles and 2 diagonals, which can't be parallel. The sum of the measures of the interior angles is 2 pi, or 360 degrees. That's if that works if it's convex like this. If it is concave like this, then that's not completely true. If you add these four up, you do not get 2 pi. But if you measure this angle here as a reflex angle, measure it around this way as 2 pi minus this angle here. So 2 pi minus 2.26 radians. If we did that and then added the four angles up that way, then that would be, it still comes out to be 2 pi. So that one's, if you count those, as reflex angles. It must have at least one angle measuring 90 degrees or more. It can't have all four acute angles in Euclidean geometry. So that's a general quadrilateral. So we're going to stop there and leave that as our introduction. And then in the next, we're going to click on each of these things sort of in succession over the next few videos and look at what we see there.